All right, 4-6 is called graphs of other trig functions. So in 4-5, we did sine and cosine, and then we're going to build on that. We're going to do tangent, cotangent, which are completely different from sine and cosine, but similar to each other. And then we're going to do secant and cosecant, which directly like piggyback off of sine and cosine. So we're going to get some more practice with those two. So the graph of tangent and cotangent are different from sine and cosine because of a couple of things. One, they have values that are undefined. So sine and cosine, as you move around your circle, there's no point in which either of those are undefined, right? Like if you think about all the coordinate points all the way around your unit circle, none of those say undefined. But when we add the tangents on, the top and the bottom of our unit circle at pi over 2 and 3 pi over 2, it's undefined. And that would be the reverse for cotangent. At cotangent, they'd be undefined at 0 and pi. When you graph something that is undefined, you get an asymptote. So if you go back to like our rational functions, the asymptotes occur where your value would be undefined. For tangent, the parent function of tangent, these happen at pi over 2 and negative pi over 2. And then you're going to have an x-intercept or a point directly halfway between those asymptotes. And then you're going to mark your A value occurs differently, or it affects your graph differently than the amplitude. The A value is how far down you go on the point that's a quarter the way in between the two asymptotes, like this guy. And then the positive version of your A value is the 3/4 the way in between your asymptotes. So we will basically find our asymptotes. We're going to have 4 asymptotes and 3 curves for for everything we do today. We're going to find the point halfway between, and then we're going to eyeball the quarter point, the 3/4 point, and mark our A values. So the process, again, is a little different for tangent, but some of the important features are here. Okay, I'm going to go over a process in a second. But the period for your general tangent curve is pi instead of 2 pi because tangent repeats every half circle. To find it, we're going to do pi over b because sometimes b is not 1. So we're sine and cosine, it's 2 pi over b, tangent and cotangent, it's pi over b. This will have restrictions on our domains, so it's not all real numbers. Sine and cosine are all real numbers, but on tangent, everywhere there's an asymptote, there's going to be a break in your domain. The range is all real numbers this time because your arrows point up and down. There's an x-intercept halfway between, and these are odd functions. They have origin symmetry. And then on the bottom it says we're going to find the points that are a quarter of the way and 3/4 of the way to give you your A and negative A. So here's what we're going to do, and this is just, I'm going to tweak this just a little bit. Actually, I think, yep, it is here. The first thing we're going to do for tangent is find A, which is still at the front. If it's positive, then my arrows point up to the right and down to the left. If it's negative, that reverses. Then we're going to find B, which is still in between the trig function and the x, and we're going to find the period. This time it's pi over b. Then we are going to set what is inside the parentheses equal to negative pi over 2 and positive pi over 2. We're going to solve for x, and those are going to be your 2 middle asymptotes. From the first one you found, you're going to subtract the period. From the second one you found, you're going to add the period, and now you've got 4 asymptotes. Then you're going to find the point halfway between each of those pairs of asymptotes, and that's the x-intercept. You're going to eyeball, so it doesn't have to be perfect. You're going to eyeball the quarter point and the 3/4 point, and that will be where A and negative A go. And then you'll literally connect your points to make the tangent curve. All right, we're going to walk through the process. So example 1 just says y equals tangent of 2x. First thing you're going to do is find A. What's A? 1. That's how low the quarter point is going and how high the 3/4 point is going. Then you're going to find B. What's B? 2. Then we're going to find the period, which is pi over b, or pi over 2. We're going to use that again in a second. Then we're going to take what is next to tangent. If it has parentheses, we grab the whole parentheses. If it's just like this, obviously we just grab that. And we're going to set it equal to negative pi over 2 and positive pi over 2. So we are shifting where our original asymptotes are. That's what this process is. So I'm going to solve for x by dividing by 2 or multiplying by a half, and I get x equals negative pi over 4. Divide by 2 or multiply by a half, and I get x equals pi over 4. Now these are your middle two asymptotes. So if I go from left to right, those are going to be 2 and 3. From the one on the left, because I want one before this, so I want one to the left of this. So the one on the left, I'm going to subtract the period. I get x equals negative pi over 4 minus the period, which was pi over 2. I'm going to come back and simplify that in a second. Because on the right, so the one to the right, I want one to the right of that. I'm going to add the period. Again, pi over 2. If you add to the wrong one or subtract from the wrong one, you'll actually like duplicate an answer. So you'll know. Like if I took the one on the right and subtracted, I actually get the one on the left. So it's not like you can get a wrong answer. Well, if you do it correctly, it's not like you can get a wrong answer. You would just get a duplicate answer, and hopefully that would be your indication you need to do something different. Okay, so now from the one on the left, I'm going to change these so that they have a like denominator. So times 2 and 2, this would be negative pi over 4 minus 2 pi over 4, and I get negative 3 pi over 4. And I write it as x equals because it's an equation. Now that's going to be the asymptote for this left. Joey.
How do you know which one to subtract by, which you add by?
So if you like, and I'm a visual person, so I tend to like, I can picture this process when I do it in my head. You don't have to do it this way. But if you always do the negative pi over 2 on the left and the positive pi over 2 on the right, you will always subtract from the negative pi over 2, and you will always add to the positive pi over 2. And then visually, these literally will go left to right on your x-axis. So the one on the right, I'm going to add the pi over 2. This was pi over 4 plus 2 pi over 4, and I get a positive 3 pi over 4. Now this is symmetric. They're not always symmetric, but this one is symmetric. Now I go to my graph. There are 2 negative ones and there are 2 positive ones, so I'm going to give myself the spacing appropriately. Negative 3 pi over 4 is the one furthest left. Then negative pi over 4. Then positive pi over 4. Then positive 3 pi over 4. Again, two left of the axis and 2 right. Doesn't always happen that way, but this time it did. These are where your asymptotes are. So I'm literally going to draw my dashed lines running through here. Then I'm going to find the point halfway between, and this has to be precise. So halfway between negative 3 pi over 4 and negative pi over 4 is what we have to find. If it's obvious, like in between negative pi over 4 and positive pi over 4, that would be 0. If it's obvious, you could just write it. If it's not obvious, then you're finding the average between those. So add them and divide by 2. So negative 3 pi over 4 plus a negative pi over 4 would be negative 4 pi over 4, which is negative pi. And then multiply times a half or divide by 2. And I know that point in between is negative pi over 2. That is an x-intercept. The same exact thing is going to happen with pi over 4 and 3 pi over 4. If I add those guys together, pi over 4 plus 3 pi over 4, I get 4 pi over 4, which is pi, and then multiply it times a half or divide by 2 to find the point halfway, which is pi over 2. Now the next part, we're going to eyeball like the quarter way and the 3/4 the way. So a quarter the way between these two asymptotes appears to be about here, and 3/4 the way appears to be about here. So we're splitting the difference between the asymptote and the intercept for all three. Then we're going to mark A. A this time is 1. So on my vertical axis or on my y-axis, I'm going to mark 1 and -1. If it was 2, I'd mark 2 and -2. If it was 3, I'd mark 3 and -3. And then at the quarter point, because this is tangent, which points up to the right and falls left, at the quarter point, I'm going to the -A. So I'm going to plot a point here, here, and here. So all the quarter points, you go to -A. And all the 3/4 points, we go to +A. And then connect. To get your curves. So again, 4 asymptotes are 3, and 3 curves are what you're going to do for all 4 of the functions we're doing today. Tangent, cotangent, secant, and cosecant. Anything with an asymptote. 4 asymptotes, 3 curves. It will be the same for your test. Questions? Let's do it again. All right, so A is what? 2. B is 1. So the period is just pi, because it'd be pi over 1. Then I'm going to take what's next to the tangent. This time there's parentheses, so I'm setting that whole thing, x minus pi over 2 equal to negative pi over 2, and x minus pi over 2 equal to positive pi over 2. Then I'm going to add pi over 2. Negative pi over 2 and positive pi over 2 is 0. And I'm going to add pi over 2. Pi over 2 plus pi over 2 would be 2 pi over 2, which is pi. And those are your second and third, as I move from left to right, second and third asymptotes. Which one do I subtract from? 0. So the one on the left, I'm subtracting the period. 0 minus pi is negative pi. To the one on the right, I add the period. And x equals 2 pi. Now I've got all 4 asymptotes. When you list these, they have to have x equals in them. You can do x equals negative pi, comma, 0, comma, pi, comma, 2 pi. But they have to have the x equals in them because they are lines. All right, now I go to my axis. This time there's only one negative one, negative pi. Then there's 0, then there's pi, then there's 2 pi. And those are your asymptotes. What's halfway between negative pi and 0? Negative pi over 2, right? Or negative 1/2 pi. What's halfway between 0 and pi? Good. Positive pi over 2 or positive 1/2 pi. What's halfway between 1 pi and 2 pi? 3 pi over 2 or 1 and 1/2 pi. Doesn't matter how you write it. Those are your intercepts. Then I'm going to mark my A values, which this time is 2. So up 2, down to -2. Eyeball your 1/4 and 3/4 points. And again, it's tangent, so we start at negative A on the left and positive A on the right. So you can see the bigger the a, like the more stretch they get. That's what would happen. If it was a fraction, it would just flatten it out a little bit. What do you think would happen if there was a negative on the front? It would be flipped upside down. So the negative on the front of a tangent makes it point up to the left and down to the right. Does that make sense? Yes? We awake? How about if I added? What happens if I said plus 2 at the end? What does that do? Shifts everything up 2. Now what's super important is with the tangent, find everything before you shift it. So like it's going to be super hard to find where your x-intercept should be if you wait till after you shift it up. So I would have done everything I just did, and then I literally would have just taken all my points and shifted them up 2, and then done my curves. Otherwise, you would not be able to find your half point and your quarter point because it's going to be like a floating axis. You'd have to shift your axis up to find it, which makes it really hard. So you're going to find everything before you shift. Okay, so here's the good news. Cotangent is almost exactly the same. There are 2 differences. The first is the overall shape. The cotangent graph looks like the negative tangent graph would look. It points up to the left and down to the right. Now, cotangent and negative tangent are not exactly the same because the other difference is where you find your asymptotes at. Where is cotangent undefined on your unit circle? If tangent's at the top and the bottom, where would cotangent be undefined?
Left and right.
The left and right. Which values are those in radians for your angles? 0 and
1.
what's the radian there?
Pi.
Pi. So instead of setting our bx minus c equal to negative pi over 2 and positive pi over 2, we set it equal to 0 and pi. So 0 and pi. Why are we not highlighting? 0 and pi. Right, take a picture of this one, because I don't know why I don't have those in your notes, but this is for cotangent. So note, almost everything is the same. You're going to find A, you're going to find the period, which is pi over B. Then one major difference is you're going to set this equal to pi and to 0 instead of negative pi over 2 and positive pi over 2. You're still, from the first one, you're going to subtract the period. Second one, add the period. You're still going to find the point halfway between. You're still going to mark the quarter point, the 3/4 point. The only other difference is the overall shape at the end is going to point up to the left and down to the right. You're still going to do 4 asymptotes and 3 curves. So everything else is the same except for this guy and the overall shape at the end. All right, let's do it. What is A here? 1. What is B?
1, 2,
Pi over 2. So the period is going to be pi over 2. So this would be pi, we're going to keep change flip, times 2 over pi. The pi's cancel and I just get 2. So just like with sine and cosine, your period does not have to have pi in it. It can be a constant or it can be a coefficient. All right, so now I'm going to take what's next to my cotangent, pi over 2x, and I'm going to set it equal to 0, and then I'm going to set it equal to pi. I always do it in that order because those will produce the middle 2. So if you keep them in that order, it makes it easier to visualize it. So divide by pi over 2 or multiply by 2 over pi, and this stays 0. Divide by pi over 2 or multiply by 2 over pi, and this is 2. And those are your second and third asymptotes as you move from left to right. Yep.
Where'd you get the 0 and the pi from?
That's what you set cotangent equal to because that's where cotangent's undefined.
Oh, okay.
Yep. So that's what changes between this and tangent. Now, 1 on the left, we're going to subtract the period, which is 2. 1 on the right, we're going to add the period. And I get negative 2 on the left. That's my first asymptote. And I get positive 4 on the right. That's my last asymptote. Well, the last one we graph. So negative 2, 0, 2, 4 are your asymptotes. What's halfway between -2 and 0? -1. What's halfway between 0 and 2? +1. What's halfway between 2 and 4? 3. Those are your x-intercepts. Then we're going to eyeball the 1/4 point and 3/4 point. And we're going to mark our A, which is 1. A 1/4 of the way in. This time we go up because it's cotangent. So the 1/4 point points up, the 3/4 point points down. All right, we're going to do one more cotangent and then we're going to move on. But notice what this starts with. What's happening now that hasn't happened yet? The negative on the front. So the negative on the front is going to flip this upside down. It does not mean you graph tangent because the process, we still have to set it equal to 0 and a pi. The shape at the end will look like tangent, but we don't set this equal to -pi/2 and +pi/2 because it takes that shape on. We start by doing cotangent. So A is 1, B is 1, period is pi. Then we set what's next to it equal to 0 and pi because this is cotangent. So x minus pi equals 0 and x minus pi equals pi. I get x equals pi and x equals 2 pi. And those are your middle two asymptotes. From the one on the left, we're going to subtract the period, which is pi. One on the right, we're going to add the period. And I get x equals 0 for the first one, and x equals 3 pi for the last one. Those are your asymptotes. I'm going to find the spot halfway between. So halfway between 0 and pi would be pi over 2. Halfway between pi and 2 pi would be 3 pi over 2. Halfway between 2 pi and 3 pi would be 5 pi over 2, or 2 1/2 pi. Man, that is a very crooked line. We're going to eyeball the 1/4 and the 3/4, the 1/4 and the 3/4, the 1/4 and the 3/4, and I already marked A, which was 1. Now, if it was positive cotangent, I go up, left, down, right. It is negative cotangent, so I go down, left, up, right. Questions? Okay, and again, if there was a plus or minus of a number after this, at the very end, the very last thing we would do is then take this curve and shift it up or down. So the asymptotes obviously stay put because they are vertical lines, but your curves would shift up or down. Questions on tangent or cotangent? Okay, I'll do this one on the video, but it's the same. Like, the only thing that changes is the A changes. Everything else would be the same. So A is 2. B is 1, which means your period is pi. And then this whole guy gets that equal to, because it's cotangent, what?
0 and pi.
Good.
So we actually use this ratio.
Yeah, you're basically moving your asymptote, the phase shift. So you don't have to do it later like we do with sine and cosine. You do it now. So I'm taking that asymptote and I'm literally shifting it left pi over 4. So that's how you're letting the phase shift affect it. So it'd be negative pi over 4. And then this one subtract. This is 4 pi over 4. And I get x equals 3 pi over 4. And those are your middle two. And then from the one on the left, we're going to subtract the period, which was pi, up here. And to the one on the right, we're going to add the period.
You always like get rid of the period in a second, like round, right? Like you add the period and subtract the period.
Yep.
And then the beginning is like negative. What's like?
So tangent is negative pi over 2 and positive pi over 2 because on your unit circle, that's where tangent's undefined, top and bottom. And cotangent is 0 and pi because on your unit circle, that's where cotangent would be. But then we're taking things like a phase shift and we're moving it with the phase shift. But the way we move it is by finding the asymptote. Does that make sense?
Right.
Okay.
Okay, I get that.
So 4 pi over 4. So this is negative 5 pi over 4. 4 pi over 4. And this is 7 pi over 4. Now I've got all 4 asymptotes. So I have 2 to the left of my y-axis and 2 to the right, but they are not symmetric. So I can't pick 0 because that's not halfway between negative pi over 4 and 3 pi over 4. I'd have to add them, divide by 2, or find the point halfway between negative 1 and 1/4 and negative 1/4. But if I add them, negative 5 pi over 4 plus negative pi over 4 over 2, I get negative 6 pi over 4 over 2. Negative 3 pi over 2, which is negative 3 pi over 4. That one was not fun. But just do that. Add, divide by 2.
Wait, could you
That was like so
say that
ugly.
again?
So I did negative 5 pi over 4 plus negative pi over 4. But then at the end, I have to divide that by 2. So from there, I get negative 6 pi over 4, which is actually negative 3 pi over 2. I reduce it.
Oh, you simplified. Okay.
Yeah.
I was like,
Yeah.
it's a bit.
You could have waited to the end to simplify, but then you would have had 6 pi over 8. Eventually, you will simplify anyways. Yeah.
Can't you just like remove the 4 denominator and add it to that last?
Sure. So same thing over here. I'm going to do negative pi over 4 plus 3 pi over 4, and then divide that by 2. 2 pi over 4 over 2 would be pi over 2 over 2, which is pi over 4. I feel like the positives are a little bit different, a little bit easier. Like split the difference between 3 and 7. And what is it? Like look at your numerators. What's halfway between 3 and 7? 5. And then you can do 5 pi over 4. So again, you would do the same thing. Add them, divide by 2. Those are your, so we just found the x-intercepts. The first things we found were the asymptotes. We want to mark our A, which is 2. And my shape is cotangent, so I start up on the left at the quarter point and down on the right at the 3/4 point.
What's like secant like? Is cotangent the hardest
Oh,
one?
that's such a good segue, Val, because we're going there next. Now we're going to go to cosecant and secant. So if you were good on sine and cosine, the good news is they directly relate to secant and cosecant. Cosecant is the reciprocal of sine. So if you look at the graph that's there, the blue curves are your cosecant curves, but the way you get to them is the little red dash line, which is your sine curve. So the first thing we're going to do is actually treat it as though it's sine. You're going to graph your sine curve. You're going to extend it because you need more asymptotes. We need 4 asymptotes and 3 curves. So I'll extend it either left or right, doesn't matter which one. And then everywhere there's an x-intercept, if I flip an x-intercept, it would give you something undefined, right? Because an x-intercept is 0. Put 0 in the bottom now, and it's undefined. So that's where your asymptotes are going to go. And then you are going to bounce your curves right off every max and min. And then the graph of secant is the reciprocal of cosine. So you would graph your cosine curve. Notice in the back here, this is your cosine curve. For this one, I just drop like half and half on either side. It's probably the easiest way to do it. Draw the asymptotes wherever you have a 0, and then bounce your curves off your maxes and your mins. This is just what it looks like. What happens if it's more narrow? What happens if it's more stretched? All of that stuff you will do by plotting your key points and then drawing your graph. So that will happen naturally when you go to graph it. All right, example 6 says graph y equals cosecant 2x. So what are we going to graph first? The sine of 2x. What's your A? 1. What's your amplitude? 1. What's your B? 2. What's your period? Remember, we're back to sine, so 2 pi over B, which is pi. There's no phase shift, there's no vertical shift, there's no reflection. We'll baby step our way there. Now it's sine, so I'm taking the first one is 0, the next one is pi times 1/4, then pi times 1/2, then pi times 3/4. Last one is the period, which is pi. So I've got 5 key points, which is what I need for sine and cosine. 0, pi over 4, pi over 2, 3 pi over 4, and pi. And then an amplitude of 1. With me so far? Okay, so I'm drawing sine, which means I'm starting at 0. I'm going up to the amplitude, back down to 0, negative amplitude, back up to 0. And my sine curve looks like this. Everywhere there's an x-intercept gets an asymptote. So I've got an asymptote here. I've got an asymptote here. I've got an asymptote here. But on everything we're doing today, how many asymptotes do we need? 4 asymptotes. So you can choose to either extend this the same width to the right or the same width to the left. It doesn't matter. And put one of those asymptotes. You don't need both. And then you will draw your curves bouncing off these maxes and minimums. So again, you only need 4 asymptotes and 3 curves, but you could choose if you want to go right or left. Questions on that one? This one, we're actually going to add 1 to the end of this because we haven't done one with a vertical a vertical shift. Let's see what happens. All right, this says 2 secant 2 pi x plus 1. What are we graphing initially? Cosine. So we're going to do 2 cosine 2 pi x plus 1. What's your A? 2, which is your amplitude. What's B? 2 pi, which means the period is 2 pi over 2 pi. or 1. And this time there is a vertical shift up 1. I'm going to take the period, which is 1. I'd start at 0. I'd do 1 times a fourth, which is a fourth. 1 times a half, which is a half. 1 times 3/4, which is 3/4. And the last one, which is 1. Yeah, sure. Then I'm going to plot these key points. I get 0, 1/4, 1/2, 3/4, and 1, and an amplitude of 2. And this time it's cosine. So we would start at the amplitude, down, down, up, up, and it would look like this. Now here's what's important with the vertical shift. You need to find the asymptotes before you do the vertical shift. So before you move your curve up or down, you need to find the asymptotes. Just because the same reason as the tangent or cotangent, that you're not going to be able to find your baseline. You'd have to move up you'd have to visualize where your axis would move, which gets way more complicated. So I need 2 more asymptotes. I'm going to drop down this side and this side. Again, I'm just kind of eyeballing that distance. It's not perfect. And then I'm going to find where my x-intercepts are. I'm going to plot my asymptotes. Then I'm going to shift the curve up 1, or you could draw your curves and then shift them up 1. That's up to you. But everything gets shifted up 1. And then the curves would bounce off of the shifted curve. So when you see this on a graphing utility, you won't see your asymptotes and you won't see your initial curve. You will just see a bunch of parabolas. Okay, you got to be smarter than your graphing calculator and know that in between those are asymptotes and know how that curve was formed was based on its reciprocal function. So if there was a phase shift here, we would have found the key points, we would have adjusted them with the phase shift, and then we would have plotted. So everything stays the same from what you were doing before, okay? Questions on any of it? Sine, cosine, tangent, cotangent, secant, and cosecant. The last slide just literally has all 6 on the same slide. That's it, okay? It goes through all of them. There is, I don't know if I published it yet because I didn't want to confuse you. There's actually an ebook that like a couple, maybe 7 years ago now, students created tutorial videos and examples, and then I put them together in an ebook. So, it's an iBook actually. It is on the module. If you need some extra examples, that's always an extra option for you. Remember, you're going to do this homework tomorrow in class. So, you have some time to work on it. Like, you'll have time to work on it tomorrow in class. And then we'll do some extra practice before we move into the last section. Your test will include either sine or cosine. So it's 3 graphs. They just take a long time. It is either going to be sine or cosine. It is either going to be tangent or cotangent. And then if you get sine, you're going to get cosecant. No, you're going to get secant so that you have to graph cosine. Does that make sense? If you get cosine, you're going to graph cosecant because that will have you graph sine. So you'll eventually do like one of each kind, but it could be any of them. It could be sine or cosine, tangent or cotangent, secant or cosecant. But there's 3 of them on there.